Okay. Hello everyone. Myself Rakesh from Sivendra College of Engineering from 8th Sem Chanakya. Today I'm going to explain about the Raspberry Pi, about its introduction, hardware layout, operating system, configuration to programming, and about wireless monitoring temperature systems in IoT. Firstly, we'll see the introduction of Raspberry Pi. The Raspberry Pi. It is a series of credit card sized single board computers developed in UK by the Raspberry Pi Foundation. Um, to promote the teaching of basic computer science in schools and developing countries. So, several generations of Raspberry Pi has been released. Now we see the first generation, which was released in Feb 2012, and it's named as Raspberry Pi 1 Model B. It has followed by simple and inexpensive Model A. The next generation, I mean second generation, was released in 2014. Compared to the first generation, it has some improved design in Raspberry 1 model B plus, and improved A plus and B plus model was released after a year. The first and the second generation was released. Raspberry Pi operating systems. Various operating system can be installed on Raspberry through SD cards. Most use micro SD slot located in bottom of the that Raspberry Pi board. It primarily uses Raspbian, a Debian-based Linux OS, which some of operating systems which are not Linux-based or RISC OS Pi, FreeBSD, NetBSD, Plan 9 from Labs and Inferno. Operating systems which are based on Linux, XBN using open source digital media center, Open is use Raspberry Pi Fedora Remix, Gelato Linux, Diet Pi, Kali Linux, Arc OS, Nerd SDK, Kano operating system. Configuration to programming Raspberry Pi. Raspberry Pi runs a Linux and supports Python out of the box. Hence, for you can run any Python program that runs on a normal computer. However, it is the general purpose input or output capability provided by the GPIO pins on Raspberry Pi that makes it useful device for IoT. Simple programs on Raspberry Pi, like print hello world, hello world. Wireless monitoring temperature systems. So, a wireless temperature monitoring system in IoT based on Raspberry Pi. Typically, it involves sensors that collect temperature data, transmit wirelessly to central hub or any server. Then it process and analyze the data for various applications. Here a basic overview of how such a system might work. Sensor nodes, wireless communication, central hub or gateway. These are devices equipped with temperature sensors such as thermistors or thermocouples that are placed in the environment to monitor temperature. These sensors can range from simple low-cost sensors to more sophisticated ones depending on the requirements of the application. Wireless communication. The sensor nodes communicate wirelessly with a central hub or gateway. Common wireless communication protocols used in Internet of Things applications include Wi-Fi, Bluetooth, Zigbee, LoRa, cellular like 2G, 3G, 4G, 5G, and nowadays around the world somewhere they are already using 6G like, and a central hub or gateway. This device acts as bridge between the sensor node and the internet. It receives temperature data from sensor nodes and might perform some initial processing or aggregation before transmitting the data to the cloud or local server. And cloud or server. The temperature data collected by the sensor nodes is transmitted to a cloud-based platform or a server for storage, processing, and analysis. Cloud platforms such as AWS IoT, Azure IoT, or Google Cloud IoT provide various services for managing IoT data. Data processing and analysis. Once the temperature data is stored in the cloud or server, it can be processed and analyzed for various purposes such as real-time monitoring, historical trend analysis, predictive maintenance, or anomaly detection. And machine learning algorithms can be applied to the data to extract insights and make predictions. User interface. A user interface such as a web or mobile application allows user to visualize the temperature data, set threshold or alarms, and receive notifications in the case of abnormal temperature conditions. Thank you.